Hello, we meet again. Bismillahirrahmanirrahim. This is the last video lectures for the microcontrollers course in the international program of undergraduate of electronics and instrumentation at Universitas Gadjah Mada, Indonesia. In the previous video, we have talked many of the features of PIC16F877 or 877 microcontrollers. So in this last video lecture, we will discuss about two applications, but you have to know that there are more than two applications out there in the internet. You can search by yourself using the Googles, but I want to let you know that what we have here is the first one, the applications according to the temperature sensor, and the second one is according to one is the I hope this represent how to read the sensor using the microcontroller, and then the second one is represent the how to controls the actuators, especially the DC motor using the microcontroller. If you want to read or to study other projects, you can visit this website, microcontrollerslab.com/category/PIC project. So in this website, there are many more than two projects right here. For example, how to use the I2C, how to use the SPI, how to use the PWM, and so on. So many things of this PIC project using this kind of website. So thank you very much for the microcontrollerslab.com. Okay, so let's see. You can read by yourself using this link of these two applications. The first one is represent how to read the sensor. The second one is how to represent to control the DC motors. Okay, so let's start for the first one. Just a minute, I have to. Okay, so the objectives of the first examples, the temperature sensor using PIC16F877 microcontroller is how to measure the temperature, to read the temperature, and then display the digital temperature, and then use the microcontroller to measure temperature and use to display the temperature on the LCD display. So that's a simple application. So for introduction, just you can read here that there are many temperature sensors available in markets, but LM35 temperature sensor is used in this project because it's the cheapest in price and you can find easily in the market. Okay, there are many other advantages using the LM35 temperature sensor. One is more efficient than the thermistor. The second is made up of the integrated circuit, hence no chance of damaging the internal circuit, and then it draws current only in microampere. You have only to 5-volt power supply which is required for the LM35, and there is no need to or extra circuit to operate. Okay, so this is, and PIC60F877 will be used to read the temperature and display the temperature in the 16:2 LCD. Okay, so normal LCD, not I2C LCD. Okay, so LM35 temperature sensors convert temperature, the physical from environment, the temperature of the rooms and so on, into its proportional analog voltage value. They have a three thermal device. I think you can see the device of LTM35 in the analog or ADC videos. So the pin number 1 and 3 is used for the power supply 5-volt voltage. So the middle pin or the pin 2 is analog voltage output with respect to temperature value. The relationship is right here. 1 degree Celsius is equal to 1 millivolt. So for every 1 degree increase in temperature, there will be increment of 10 millivolt in output voltage of LM35 sensors and so on. And then I think it's for the PIC877 microcontroller, which is used to measure analog voltage value. You can read like this, and you can make other project using this kind of microcontroller. This kind of microcontroller already used in the nano satellite. It's my teacher is my professor from the Japan, Professor Miyazaki. Uh, they use the PIC16F877 to their satellite, their nano satellite. So this is very robust. It's very good microcontroller, I think. The other example, you can use this kind of microcontroller for example, greenhouse system project using the ATC channels to measure temperature, measure the intensity of the light, humidity, and also the moisture. So if you want to display the reading of this kind of uh, environments parameters, you have to convert or first reading the ATC value, and then you should convert this ATC value according to the parameter for this kind of environment. So you have to convert this using the microcontroller. All this conversion has been done through programming, and then you can display this kind of the measurement using the LCD or maybe using other display, maybe OLED and so on. So this is the circuit, our simulator circuit. So this can represent the LM35 sensors in the Proteus software. This kind is for the, I think, for using 4-bit interface, but not the ICE classic. So the LCD with temperature display, for example, temperature equal 11 degrees Celsius and so on. So this kind using the first channel of ATC 0 to measure the temperature right here, and then convert in the program and display it in the LCD. So this is the declaration is our in the program, the declaration of the LCD itself for the data. We use the 4 data, T4, T5, T6, T7, and also enable pin and RS pin. The direction is according to the 3 because we use 4P here. And then we have to declare the temperature itself is integer, and also temper is character to display the temperature in this LCD. So this one is to read the temperature using ATC read. So you have to convert right here, temperature multiplied by 5 divided by 1023, and then multiply again by 100. And then you have to convert the data, the temperature using, because the temperature is global variable. So the procedure can use this kind of variable. So this one is to convert integer to string. Where is integer to string? Okay, integer to string here. And then after you can display the temperature using the display one. So this is the main program, ATC init, LCD init, LCD command, LCD clear, LCD cursor, using the micro C LCD library, digital parameter sensor, delay 1 second, and clear. And then you can read the temperature, data conversion, and display. So The result is just like here. You can visit this YouTube channel. Okay, just a minute to connect to the internet.
Here sensor LM35 can easily we can calculate ADC resolution setting. We can correct it. So here
So this is the result according to the program. So you can click this YouTube uh, from the items. Okay, so the display will be just like this, just like this. Okay, this is the example of the result. Okay, so that's the first our first example. So we have to go to the second example, which is represent how to control the motor speed, especially the DC motor speed using the IC microcontroller. So there are many applications of DC motors where we need variable speed of DC motors. For example, it has application in electric cars, trucks, and aircraft. And these are three examples where we need variable speed. Although nowadays AC motors have more use in the market for variable speed application over DC motor due to enhancements in power electronics and solid state electronics. But DC rotational machines are still used today in many applications for variable speed requirements. Okay. So according to the armature and field current circuit configuration, there are 5 types of DC motors. DC motor with separate excitation, shunt type, series, compound, and also with excitation from permanent magnet. The speed of separately excited DC motor and DC shunt motor can be made variable by changing terminal voltage and by changing the armature resistance. So this is technically how to control the DC motor according to the, the behavior of the DC motor speed itself. Uh, and how to control the DC motor? Just you can see you can control the DC motor speed using the voltage regulator and also the PWM. In our example, we will use the PWM. You can read the introduction how to control the DC motor speed and the website, and also in this video you can pause right now to read this kind of introduction how to control the DC motor speed. Okay, okay. Uh, Thus, I mentioned before that you can control the DC motor using the voltage regulation or using the pulse width modulation. In this example, we will use the pulse width modulations. So this kind of the voltage regulators have a symbol, but it's not practically visible or recommended. And also the standing is also costly. But we can use the PWM, just we have discussed in the previous video in the PWM lectures to control the speed of the DC motor. Okay, so this one is according to the PWM. I think we can use the PWM. You can generate the PWM not only using the microcontrollers. You can buy some of the integrated circuit that generate the PWM signals, so you can control these PWM signals not from the microcontroller but from the some of the integrated circuit. But uh, in this example, we can control PWM signal using the PIC microcontrollers. Okay, so this one will be our discussion in this example. So if you want to have a dedicated PWM controller, you can buy the SC3525 UC3842, SG2525, and many others. So this is the PWM controller IC, which is used analog electronics method because their internal circuitry consists of operational amplifier, resistor, and capacitors. So there are few issues with this ready-to-use PWM controller ICs. Most important issues is three issues. First, you will require many extra components to make them ready to use. And then the exact frequency is not achievable, especially 1 to 2% error. And there is also frequency limitation, which in some cases generate audible in motor or noise. Okay, but if you use the PWM using the microcontroller, there are no such issue with pulse width modulator of digital electronics type. Okay, so what we have here, we have Proteus schematics. This is variable resistor. Okay, to this variable resistor is to use to control the DC motor here in the Proteus simulator, and the DC motor is controlled using the RC1. This RC1 is according to the PWM2. Still remember? Okay. RC1 is according to the PWM2. RC2 is according to PWM1. So this PWM is fed into the fed as a switch transistor. So you can I think you can controlling using this switching transistor right here with a pull down resistor. So from the fed you can see that this kind of circuit is like have a switch right here, and then to secure the DC motor you have to parallel with the diode. So the DC motor cannot harm the microcontroller itself because we already placed one diode parallel to the DC motor to anticipate the feedback current to this microcontroller. So it will be safe. So okay, the PWM frequency is tuned about 8 kHz, which will not make any audible noise. But you can adjust according to your motor specification. So IRL 104, the FET, is used as switch. It requires only 5-volt logic level driver to operate the FET and negligible amount of current. Therefore, there is no need for any driver to drive IRL 1004 FET. It can handle more than 1 ampere current very easily, as it is mentioned in its datasheet. The other is diode 1N4007 is used as a freewheeling fast recovery diode. Why? Because the motor is inductive load and has its back EMF may damage the circuit. Freewheel diode will provide flow path to back EMF current and avoid sparking across motor terminal. So this is for the safest of the circuit. Okay, so anticipate the electronic magnetic fields according to the design methods, which can harm the circuit, all the circuit, especially for the PIC itself. So you need to place this kind of diode to anticipate this kind of harm effect. Okay, so this is the program. The main program. You need to first you need to configure the port A. Some some of the pin is for output and some of the pin is for input. The 3-way, only the first pin is input, the others is output. 3C is all the outputs. So the port A, port B, port C is initialized by 0, CCP con 1, CCP 1 con, just we have already learned about it. Select the PWM mode, and the PR2 is 1000, the cycle time to 1000. CCPR1L is 50 by default. The duty cycle is 50. TMR2 on bit 1 is the start of the timer for PWM generation. ADC init, okay, because we will read from the potentiometer. ADC value is equal to ADC read the first channel. Give some time 100 milliseconds, and then if the ADC value is not equal to the ADC value old previous ADC value, then it has a new value. Then CCPR1L is set to the ADC value right now, the current ADC value, and then the ADC value 8 is equal to the current ADC value, and so on. Okay, so this is for the for the CCP. Okay, the CCP is according to the CCPR1 ADC value, and then you can learn about the signal in the digital oscilloscope. This illustration is for the 40% this cycle. Okay, so you can watch the result in this YouTube channel. So future recommendation of this application is you can have a feedback control mechanism to ensure constant speed, and you can control the direction of the DC motor using 8-speed circuit, and you can try more than one motor. But it's interesting one is maybe you can make it your final project is speed control of DC motor through wireless communication like GSM, GPRS, Bluetooth, ZigBee, and many other wireless communication techniques. Or maybe we can call the IoT controller of the DC motor. So you can measure the speed of the DC motor itself, and also you can change the direction of the DC motor itself, and then you can control maybe more than one motor DC, and you can control wirelessly. Whether you can use the Bluetooth, you can use the internet connection, which is called Internet of Things, something like that. So this is the interesting one for future recommendation of this kind of example. Okay. So the other example, many examples of the PIC microcontroller, you can watch it or you can read the articles in microcontrollerslab.com. As many projects you can watch, you can learn, and maybe you can practice it, or maybe you can develop more of the projects. And I think if you want to fully understanding about this microcontroller, you have to learn more and more, practice also the concepts, practice and also the theories. But the practice make it perfect. Okay, so I think this two explanation of the two application explanation for you, just to motivate to you to learn more and more about the microcontroller itself and also the application. Maybe in the Arduino, maybe in the other PIC series, or maybe in the STM32, or maybe ARM-based microcontroller, the other microcontroller, or maybe you can learn about the new microcontroller for the Raspberry Pi, for example, Raspberry Pi Pico. You can search for yourself about the Raspberry Pi Pico in the Google or in the many of YouTube channels. Okay, I think this is the last videos of the microcontroller lectures at the undergraduate electronic and instrumentation program, Department of Computer Science and Electronics, Ustaz Gajah Mada, Yogyakarta, Indonesia. Thank you for your attention, and we will see you in the other lectures. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.